Thank you, everyone, for joining us today. As Yasmin mentioned, my name is Mike Canney. I've been in the industry for about 29 years. The majority of that really focused on application network performance at the packet level. So today we're going to be talking about identifying and diagnosing performance issues in as simple of a workflow as 4 clicks. And so I just have a few slides to kind of get us started here. About Exedian. So Exedian was established in 2005, so we've been around for quite a while. In over 75% of the top 50 communication service providers. We do have a global presence. You can see offices really around the globe, and over 40 patents on our solutions. So what we're going to talk about today again is the PBX Skylight solution and really where it fits within an organization, right? So today we're going to focus primarily on avoiding the performance degradations, but I did also want to include other things that the Skylight PBX has in its wheelhouse and can be used for multitudes, and we kind of call these the 4 pillars of performance use cases for PBX. The first one is troubleshooting faster, right? So a user calls into the help desk and complains that the quote-unquote network or the quote-unquote application is slow. And we're going to kind of work through some of those workflows today in the demo session, but really what it boils down to is that mean time to innocence or mean time to resolution in some cases. So being able to very quickly see in that performance degradation, where was my bottleneck? Was it the client, the front-end server, the back-end server, or the network, or the application? Right? Another thing that you can use this for as well is for proactively looking at your network and being able to see what the traffic looks like today. And if you have any migration projects coming up where you're moving data centers, a lot of our customers will use PBX to not only baseline what the traffic looks like, but also how the application is using the network. So being able to do some predictions of how this application is going to perform if it is indeed moved to a different data center. Also allows you to put together application dependencies in that same breath of being able to find out, okay, what servers need to move together in those data center migrations. And then the last one on here, collaboration, it's really about bringing the IT teams together, right? It's not a tool that essentially points fingers or a tool that one department brings out as kind of a club to beat the other departments over. Really, it's a real collaboration, and as you'll see kind of during the demo that it's got all aspects, right? It's applicable to, from service desk to network engineers to DevOps to sysadmins, right? It's a unifying tool for the IT group. So how does PBX work? So I kind of mentioned here that we operate off of packets or at the packet level. So in your typical environment, PBX is going to be looking at wire data, right? So that means sitting off of a mirror port of your switch or sitting off of a tap. Again, in a physical environment, or a lot of companies will deploy port aggregators that actually will consolidate that mirror traffic. But essentially, we're sitting there passively on the wire. Again, not adding any overhead, just listening 24/7 and analyzing and decoding that traffic in real time. That also leads into the data store can reside anywhere on your infrastructure. The capture appliances are typically the devices that you want to get in front of the traffic. So we are software-based primarily, so that means being able to not only capture that at that physical location, at that tap of that mirror, but also to capture in a virtualization environment. So in your vCenter ESX environment, which also kind of leads into the cloud as well. So with that, and with the understanding of kind of how PBX works, what I'm going to do is I'm going to jump right into the demo. And this is the typical workflow that a lot of customers will use. As I mentioned, a call comes in to the help desk or the service desk that the quote-unquote network is slow. One of the very cool things about PBX is that we're capturing this data in real time, but we're keeping it long-term, right? So if a problem, for example, maybe there was a help desk ticket that said, the problem happened last Tuesday at 2 o'clock in the afternoon, you can simply tell PBX what time frame of data you want to look at, and you can essentially have this time machine and go back in time and say, okay, the call was reported or the performance issue occurred last week or last Tuesday at 3 o'clock. Let's go look at last Tuesday from 2:55 to 3:05 and see exactly what happened on the network. Likewise, we have this ability to, again, within this dashboard, this is our critical applications dashboard. So a lot of times what customers will do is when they get PBX, one of the things that they do when you plug this in is it automatically starts learning about the applications and your network traffic. It also allows you to classify some of those proprietary applications you might have, or which contain groups of servers, groups of users, etc., and classify those as business critical. And when those are classified as business critical, what it does is it'll monitor. You can see here kind of this these different applications going from green to yellow to red. Again, just as you might think, green being within the threshold, everything's working fine. The yellow being starting to kind of go out of what's normal or out of that expected SLA, and then red being things are definitely in violation, right? A critical error, critical warning. And what's great about this is, so for example, in that use case that I said users calling in complaining things are slow, in this case we've got users complaining that the ERP application is slow. So ERP being one of our critical applications for this specific customer, you can see as I kind of mouse over these different time slots, we have a bunch of statistics that show up here. And the top one, which is labeled as EURT, is end user response time. So essentially what that is the time that user hits enter, or the time that user clicks on an action to the time that screen came back, right? So we're looking at the actual business transaction per se of this specific end user, and we can see that at certain times, like for example here at 8:07 a.m. it flagged red, and we can see the EURT, or the end user response time, was 4.6 seconds, right? Whereas when it was in the greens, it was less than a second. So we definitely have some problems throughout this time period. But if I focus again on that one where we've got this pop-up, we can see that along with the EURT, or end user response time, we have a host of different metrics. We have RTT, which stands for essentially latency time in both directions, the round trip time for the client, round trip time to the server. And then we have one called SRT, which stands for server response time, which is essentially the time that the server gets the request, the time that the server acts upon that and actually sends data out. And then we have the DTT, which is the data transfer time, again, in both directions. So in this specific example, we can see out of that end user response time, that 4.6 seconds, 4.3 of that was due to server delay. Right, so even from this high-level visualization of my performance, I have a good idea or a good indication of, out of that slow end-user experience, what is causing that, right? In this case, again, we see here another end-user response time of 2.7 seconds, 2.3 of it being server, right? But typically, what we want to do if we're troubleshooting this problem, right, is to drill in deeper, right, to get more detailed information. And one of the things we provide, again, as part of this, this 4-click workflow in PBX, is the ability to come in here and look at the application dashboard, right? So as I mouse over that, hit application dashboard, what this is going to do is it's going to drill down into this specific time period. And the first chart we're presented here with is the overall user response times graphed out. And we can see here that about 7:53, we had an average response time for all users of the ERP front-end application of about 25 seconds. And the majority of it is colored blue, indicating server delay, right? So one of the really cool things I can do with this as well, if I wanted to find out how much of this overall user response time was due to network time per se, I can simply check that box by server response time to uncheck it rather. And now I can see, you know, we had kind of a spike here of data transfer time at about 2 seconds, but during that overall, you know, 24-second response time, the network was really only responsible for about 500 milliseconds at that time. So you could do that for any of these different statistics. You can turn them on, turn them off, etc. But again, it just kind of highlights the impact for this specific instance of server delay. Now, as I scroll down, one of the next chart we can look at is also the number of transactions, right? So as I mouse over that long server delay, one might think that, hey, that server is probably overwhelmed. And in this case, we can see during that time there was only 2 transactions for this application running. So again, something else wrong, right? Potentially not a CPU related issue. And as I scroll down even further, on the left-hand side, we'll see and show all of the servers that are involved for that transaction. In this case, there's just one. And on the right-hand side, we've got a breakdown of the remote locations or zones, as we call them. And we can see that the only site that is having response times issues is Lille here. And they're having, on average, an 11.68 second server delay with an average response time of about 11.3, 11.4. So the next step here, again, is that this peeling the onion workflow of clicking on Lille to drilling in deeper to see, okay, now show me just the users of Lille and what their experiences are. And now we can see as we kind of drill into this that they're having a lot of problems, a lot of server delay, again, being blue, some response times up over 50 seconds. Of server delay. Again, as I scroll down, we can see there's not a lot of transactions. Likewise, in the last graph, we're gonna see the servers involved, but more importantly, in this specific drill down, we're gonna see the individual end users, right? So these are all of the users at Lille that are running the ERP front-end application, and moreover, a breakout of what their experience was and the cause of delay. Right, so we can see that this user here at 172.16.2.115 had an average response time over this hour of 18.2 seconds, and 17.4 of that, on average, was due to server delay. Right, so again, we can see the individual users, how they're impacted, and again, our next click, right, in our 4-click workflow is on this magnifying glass to drill in and see everything that this user was doing, right? So this is going to show us all the connections, all the transactions that this user had for ERP front-end application. And oh, by the way, we also have, for those Wireshark or PCAP fans in the audience, the ability to drill down into a PCAP that was captured automatically. So one of the options, again, I mentioned in the beginning that we operate off of looking at the wire and looking at the packets. One of the options within PBX is to say, hey, if we violate a threshold, right, if there's a critical warning, save me off the PCAP file, right? So I can simply click on this PCAP file. It downloads, and now I can click down here if I wanted to and open this directly up in Wireshark, and now I have the packets for this specific problem, right? So moreover, the other capability here, kind of in the next click, is being able to come over here and click on HTTP, right? So we've recognized that this ERP application is HTTP, and as I drill into that, what we're going to see now is every single HTTP call that user made for this application and how long it took, down to the specific URL, right? So in this case, I can come over here to the right, and I can sort based on hit response time, and I can see that I got, this page took over a minute. This page here was 58 seconds. And again, for the kind of the last click, right, to be able to drill into this, I can come down and say, you know, I want to inspect that HTTP header and potentially, again, turn this over to the sysadmin or the developer, depending on what the application is, and say, hey, look, this is the call that's causing us a lot of server delay. And again, in this case, we can see 58.2 seconds of server delay. This is what we want to focus on from a server system, potentially code issue. So that's the 4 clicks to finding performance degradations. One last thing that I'll kind of go over here, and then we'll open it up for questions, is that PBX, you can also see here in conjunction, we've kind of been focusing on a web-based performance problem, but we also have these deep-level decodes for the DNS protocol, Citrix, voice over IP, multiple flavors of SQL, including MSQL, Oracle, etc., as well as, you know, various ICMP network-related protocols as well. But this was the 4 clicks to getting to a resolution very quickly.